All right, guys, we're going to take a quick look at, this is number 60 from the chapter review, and it deals with the Richter scale. And we spent a little less time going over this than some of the other stuff, so I could see how it could be a little confusing. This question, though, if you understand the Richter scale, this question can actually be a really quick one to answer without really even doing any work because of the way that it's worded. So basically, the Richter scale, the way it works is if you want to have 10 times the magnitude or 10 times the ground motion, you go up 1 on the Richter scale. So a 4.6, if you go to a 5.6, that's 10 times, or tenfold is how you could say that, a tenfold increase in magnitude. So if you want to go 100-fold, you'd go up 2 full numbers on the Richter scale, from 4.6 to 6.6. And if you want to go 1,000-fold, if you want to get 1,000 times greater than the first, then you're going to go up 3, that exponent on 10 right there, 3 numbers on the Richter scale. So from 4.6 to a magnitude of 7.6 is a 10 to the third or 1,000-fold increase. Now, if you want to know, like, what does that look like in terms of an equation, right? Like, what if it wasn't 1,000? What if it was like 1,050 or, some other number that's not a power of 10? We can actually do that too. And so the way we got the Richter scale equation is we were told that R of I, which in this case, in other words, the Richter scale of a particular intensity is in this case, it's 4.6, right? That's the first earthquake. Is equal to the log base 10, so just the log, of I over I sub 0, I naught. And that I sub 0 is like that 0 earthquake intensity. It's like a really, really weak earthquake. And if you take that equation that I just wrote, that 4.6 equals that logarithm, log base 10 of I over I naught, you can actually exponentiate with base 10. And so you get 10 to the 4.6 power equals I over I sub 0, I naught. And you could actually plug that into a calculator, 10 to the 4.6 power. It's going to be somewhere between 10,000 and 100,000. At 4.6, I'm guessing it'll be probably like 40 to 50,000, somewhere in there. I'm not sure. You could try it on a calculator and see. I'm just going to leave it in this form, though, because this is convenient enough for us. And what I want to know is, 10 to what power is going to be 1,000 times stronger than that? So this right here, this is like the comparative intensity, right? This value is how many times stronger than the 0 earthquake a 4.6 is. Well, if I want it to be 1,000 times stronger than that, I'm going to take that 10 to the 4.6, however, 40, 50,000 times stronger than a 0 earthquake, whatever that is. And I'm going to multiply it by 1,000, by 10 to the third. This is how you make it 1,000 times stronger. And when you multiply like bases, you just add the exponents. So 10 to the 7.6, whatever that is, which is 10 to the 7th is 10 million, 10 to the 8th is 100 million. So this would be probably like 40 to 50 million, basically, right? Yeah, that's it. So that's the intensity, right? We took the relative intensity of this, and we multiplied it by 1,000, and we got this. And again, it's like some number, like 40 to 50 million or whatever it is. But the Richter score is that exponent on the 10. And so that's the answer that you want, 7.6. You don't have to do all this work for this question. But if that number, if it wasn't 1,000 times stronger, if it was like, let's say it was 1,100 times stronger, then what I would do is I would take 10 to the 4.6. I would actually take that value. I would multiply it by whatever number I wanted to multiply by, right? So this is a different question now. I could multiply by 1,100, let's say. And this would represent like 1100 times stronger. And I'd get a number there. And what I want to know is 10 to what power equals that number. So I would just take the log of that, whatever that is, right? I don't have a calculator app on this, but yeah, whatever you'd get, like you could take that 10 to the 4.6, you could multiply it by any multiple you want, get the new kind of intensity as a number, and then if you take the log of it, that'll give you the Richter score. Okay, that's all there is to that. I hope that helps, and I'll probably do another one here in a minute.